So let's start.
Okay.
Very much looking forward to hearing you.
So I'm going to talk about our experience in retrofitting buildings at Trinity. Okay, how does this work? But my background is I was in the same year as Martin, but I was at St. Catherine's, mainly because I applied there because it was much nearer to the faculty. But I then went to work for James Sterling and Michael Wilford, and the first kind of built project I did was the Tate Gallery in Liverpool. And whilst the style and colouring is all idiosyncratically Jim Sterling's own, the real eye-opener for me was how you exhibit art in a pretty harsh maritime environment, how you protect nationally important artwork from salt, basically, and the effects of humidity. And so designing the gallery spaces in there as protective environments for sometimes pretty frail art pieces was the thing that got me thinking about climate and the effects that a changing climate was going to have on our living conditions and humans as actually still relatively frail organisms. I then went to work with Richard McCormack and built the Ruskin Archive in Lancaster. That's a collection of the writings, daguerreotypes, fossils, all of the ephemera of John Ruskin's life. And it's a national archive building, but there is no air conditioning. We managed to design it in such a way that the outer walls, heavily insulated and airtight, create an environment that's fit for humans to look at artifacts and sit in the reading room. And then there's an inner volume, which is the red Venetian rendered box within, that actually buffers further down to the archive itself. And the conditions in the archive are stable to within the rules determined by the British Standard. And that, so it's a very low energy building. It was built with a National Heritage Lottery grant.
Can I interrupt for a second? What about the airflows? I mean, that's also quite important, not so you don't get.
Well, we discovered this thing called mechanical ventilation with heat recovery. A wonderful thing. I have it in my house. I put it into all the buildings at Trinity. You take fresh air and you temper it with the heat from the outgoing air. So you recover the heat from extracted air, and you can filter it and modify its humidity and so on for use in the archive itself. But it provides a almost perfect environment. I mean, again, you'd have to desalinate it if you were in Liverpool, and it would be more complicated. But at Lancaster, it was fine. So the next project, the last project I built at McCormack's was the chapel at Fitzwilliam College, which departs from the Lasden master plan for the college and faces into a tree, which turns out to not be such a good idea because the tree is undermining the building, and we're dealing with some movement now. And then I set up Fifth Studio, and we have so we're 25 years old this year, and we have studios in Cambridge, Oxford, and London. And so it's the kind of golden triangle in terms of the kind of clients we want to work with, which are the colleges, because they're stimulating and interesting and always interested in, in the post-war era, it was the Oxbridge colleges that really explored the kind of post-war housing paradigm. Buildings like Wolfson Building at Trinity or Wolfson Flats at Churchill were really exploring new ways of building housing, and they are at the forefront of exploring how you deal with climate change. London we have a London base simply because the architectural and building consultancy world in the UK is so London centric, and it's almost impossible to avoid having a presence in London. That's my team. That's actually yeah, we've grown a bit since then, but there's 24 of us there. So this is my partner, Tom Holbrook. And yeah, it's a good team of people who've been with us for a long time now. And these are the spaces we work in. So the top, there's the studio in London. The bottom left is the studio in Cambridge. We're having a bit of an event. And then we've got a shop front in Oxford, just off the High. And we've got a space in London that we use for big client meetings, because we have an open plan, non-hierarchical office. And the kinds of clients we work with more or less split between colleges and local authorities. They're clients who have a long-term interest in their estate. So we do relatively little work for commercial developers, simply because the kind of approach we have brings greater long-term benefits, but not that immediate payback that a commercial developer is perhaps looking for. And the range of work we do covers, well, it's enormously disparate in scale. So we finished a few years ago the work for the National Infrastructure Commission, which was a government department, looking at the provision of housing within the Oxford, Milton Keynes, Cambridge arc. That's 1.2 million houses that are going to happen anyway due to market pressure. And how do you situate those that makes most sense of the available and or planned transport and water infrastructure? You know, we're in a water stress area over here in the east of England, and there's no point building 1.2 million houses if there isn't enough water for them. So that was a very high level kind of regional strategic piece of planning work and exploration. And at the other end of the scale is the restoration of Oriel College, which is 17th century, but with significant alterations in the 19th century. And it was about how do you restore something without it losing its slightly battered character. You know, how do you do something that still shows its age and its scars, whilst being fit for 21st century kind of human habitation. So we made that as sustainable as possible by insulating the roof and making sure the windows were airtight and putting underfloor heating under the floorboards, which got away from that thing of having hot radiator pipes under some benches and freezing cold in the middle of the room. So that's the kind of spectrum of projects that we're doing. And the impetus for making existing buildings sustainable is simply this now very kind of hackneyed or well familiar argument that buildings consume about 45% of our energy. 85% of today's buildings are going to be there in 2050, at which point we're going to be ostensibly at net zero. We've got a legal, in the UK, there's a legal commitment to be there. And actually, all existing buildings are going to need a major retrofit in order to be able to live within the amount of energy that's going to be in a net zero 2050. Trinity itself has very limited options for new build. When I was at McCormack's, we were building Burrells Fields, which is the development right at the other end of the college site on Grange Road. But the color coding on this plan shows the pale blue is grade 1 listed buildings. The darker blue or purple are grade 2 listed buildings. And such is the intensity of conservation concern in central Cambridge that it would be enormously difficult to get permission to knock one of those down and replace it with a modern building. So we have Trinity have very limited options for new build, and therefore needed to make the most sustainable use of their existing buildings. You know, and at the same time, they can't all become museums. They have to have an ongoing economic and viable use. A bit more context. So the National Grid here published future energy scenarios every 2 years. And the first time these came out, I was looking at a figure that said, oh, there's 177 terawatt hours of energy available for housing, and that includes residential buildings. There are four different kind of scenarios. There's kind of do nothing and really ambitious. But you take 177 terawatt hours and you divide it by the square meterage of all the houses and residential buildings in the UK, and you find a number that's not much bigger than the passive house level of energy use. So there's actually, there is a supply side constraint on the energy available to our buildings in 2050. There's a much longer calculation behind that, but I have published it and I can send it if anyone's really interested. But the rooms in Trinity, whether in the Wolfson Court on the Wolfson building on the left or New Court on the right, were no longer really providing contemporary standards of comfort and amenity, and certainly not of energy efficiency. So the bursar, Paul Sim, who was the junior bursar at the time, asked us to look at the Wolfson building. And sorry, I'm going to step back a bit. The constraints on retrofit are listing and the approach of heritage agencies. The constraints on decanting whole populations of students from buildings while you retrofit them. There's the constraints of the college calendar and exam terms, and in Trinity's case, the fact that you suddenly discover you've got a whole of New Court occupied by builders, and you suddenly discover there's a royal visitor coming, and everything has to stop. Absolutely everything cleared up. No contractors on site. The whole thing dressed up as if nothing was happening. And the final constraint is the lack of experience in the construction industry and the way in which we are not teaching people our building trades to work with historic materials and techniques. So Paul Sim, the junior bursar, asked us to look at the Wolfson building, built by Architects Care Partnership in 1972. It was the first building I ever studied with my supervisor, David Roberts, in the first week of the first year. He said, "What do you make of this then?" It's a pretty classic brutalist building, kind of with a kind of tectonic architecture of kind of stacked and stepped blocks. It's pretty unyielding. That's the view on the left from Sydney Street, and on the right from the raised plinth, which sits on top of Sainsbury's at the Sydney Street end and Heifer's on the Trinity Street end. That proved to be a bit of a constraint because you start hammering a concrete structure 7 floors above and you can hear it in Heifer's. They weren't very happy about some of this. But that's a photograph of at kind of in its first year of use. You can tell that because of the little record player on a little table. But classically, a student sitting with the window open and the radiator almost certainly on full. Because the rooms were actually very stuffy if you didn't open the window, but they were very cold when you did, so you turned up the radiator. And that was a problem on day one, and it was a problem when Paul Sim asked us to look at this building. More recently, it's been published in the Cambridge Alumni magazine, the Vice-Chancellor revisiting his old room and talking to an undergraduate, and you can see there the nature of the retrofit we did. So double glazed window, highly insulating, a service paneling that allows the college to go in and repair or alter or maintain all of the pipes and cables without having to hack off the plaster or lift the floor. And Paul's brief was a service-led refurbishment of the building with upgrade of student rooms. And what we did there was put in wall insulation on the inside face. It was a cavity wall building. We talked about the idea of filling cavities, but I mean, a cavity wall construction is a complete nightmare, and I don't know why we ever invented it as a profession. They always fail. And the idea of trying to insulate it and know that you'd fully insulated it seemed to be beyond sensible. We installed double glazed windows. We repurposed the original kitchen extract ventilation system to provide MVHR, to provide tempered fresh air to every room. and extract it through the gyps and the bathrooms and the shower rooms and so on. And as I said, we built this accessible service lining for alteration or maintenance of pipes and cables and stuff. And this is a completed room. We couldn't persuade the college to lift up the floor and put in underfloor heating, but we have got a very much smaller radiator to adequately heat the room. And we've improved the insulation of the walls and windows. And my understanding is students are very happy. I tried to get the college to do some research. There's some research done in the Danish Technical Institute that says if you give people really good air quality, they perform much better. And there's evidence of that research done in schools. And I asked Trinity whether they were prepared to kind of look at the gradings that first-year undergraduates achieved and whether it had changed after they worked to the building, but the college weren't prepared to do that, and probably quite rightly. On the roof, we achieved a first in central Cambridge, which is covering the roof with photovoltaic cells. They deliver an output which matches the energy required to run the MVHR system. So those things are kind of self-sustaining system without a major draw on the college's electricity supply.
Oliver, can I interrupt here at this
By
point?
all means, yes, please, anyone interrupt.
Sorry about this, because Dennis sent a message here. He wanted to ask about the photovoltaics on top of King's College Chapel. You know, what do you think about it? So I thought rather than waiting to the end, it would fit here, I think. What do you think?
Well, I think it's brilliant. I think the Cambridge City have an aspiration to not only reach net zero, but to manifest that ambition and that achievement. And you won't see those photovoltaics on the roof of King's College Chapel from anywhere unless you're in a hot air balloon. So actually, the idea that you are, and the idea that it's being talked about, and that you're generating electricity in a building which is probably not going to have any other level of retrofit installed in it. No one's talking about insulating the ceiling in King's College Chapel, or the windows, or insulating the floor. It is far too precious a building. So the idea that you say, well, but here's a roof that no one can see, it's got a really good orientation, let's generate electricity from it, I think is the right kind of thing to do.
Dennis, does this answer your question, or do you have some comment?
Do you agree?
I totally agree. But it seemed to me to be absolutely the right thing to do. Unfortunately, by the looks of it, or by my recollection, there aren't too many roofs in Trinity that sort of fit that criteria, where you wouldn't see the impact of solar cells. So perhaps it doesn't set a useful precedent.
You can't see them on the roof of Walsam from the ground.
Okay, on the walls, but on the rest, I mean, on the more historic buildings, you can see all the roofs.
We got consent. So we got consent on New Court, which I'll come to put photovoltaics put photovoltaics on the south-facing roofs. And the college haven't yet done that, but the consent is there. And the argument in planning was, Historic England was saying, oh, it's going to change the character of this Grade 1 listed building. As you come over Garrett Hostel Lane Bridge, you'll see them. And the councillors said, yeah, that's the point. That's what we want. We want to demonstrate that the colleges and the city of Cambridge are responding to this potentially existential threat, and we're doing everything we can. And a change doesn't necessarily have to be for the worse.
I mean, there's also Adrian House and Butler House, where I had one of my, when I was a fellow, I had one of my two teaching rooms there, and I also lived the first year of my PhD in Butler House. So Butler House roof, I mean, that might be also suitable for solar, no?
Well, yeah, it's so complicated, that roof. I mean, it's a collection of pyramidal roofs.
It's never on the roof, you know.
It's a David Robert. I mean, I suspect those buildings are due for a retrofit, and I hope that photovoltaics will be part of it.
Okay.
You could do it on the chapel, couldn't you? Because anything that's low pitched and sort of lead finished, you could
behind a parapet.
Yeah, you've got a parapet as well now. So
Yeah.
and there may be ways of designing the thing so that it doesn't look out of place. I mean, if you can get it into the same plane as the roof, for example, then it could. It's sort of the color of slate, really, isn't it?
I think there's a kind of performance issue with getting it into the plane of the roof, which is that they don't work very well if they get hot. So you need a kind of really good airflow under the back of them.
I see.
Which is why they tend to sit up on frames.
Mm.
But that technology is changing so fast. I mean, there is a product being developed in Cambridge which uses plant polymers rather than silicon to make a photovoltaic cell. At the moment, they're only about 20% of the efficiency, but they're much cheaper to make, and they're clear. So the discussion there is, can we build them into the facades of, instead of windows, or as part of windows? Not perhaps in the windows of listed buildings, which tend to be very small format. And the pandemic has knocked the bottom out of the building new office buildings market. But things are changing very quickly in the world of photovoltaics, air source heat pumps, and so on. And watch this space, I think. But no, I'm all in favour of the photovoltaics on King's College Chapel. So what we did internally, and I don't know how many of you remember the Wolfson building, but it was a pretty dark, foreboding interior. So we've replaced all the heavy glazing around the staircases and put in fire-rated clear glass, and the college insisted on a kind of colour coding of the floors, because that's the other aspect of that building, is you couldn't really work out where you were until you got to the top. And then from the in the underbelly of that kind of stepped ziggurat form, we hung a couple of rooms, which were sort of free space, really. And they increase the kind of social space component of the buildings, but they also form teaching rooms. And talking to teaching fellows there, they say, well, every other room in the college is a room with a wall and a window aperture in it. What's fantastic about the rooms, and they're called the hanging rooms, actually, about the rooms in Wolfson, is you're just there in the landscape. You're there in the architectural courtyard. Some issues with glass floors, but I really like them, and I think people have learned to love them. So that's the view from the Garden of Eden, from Whewell's Court, with this kind of crystalline glass room, and that's the view underneath it, with a kind of flat black glass soffit. So these were really just an extra, and to the college's, when we came up with the idea, to the college's enormous credit, they just said, yeah, we love it, do it. So so that's the view from Whewell's Court, and that's the view from Blue Boar Court at the back. And partly what these things do is they reinvent the image of the building as well. So whilst you've reinvented, you've kind of upgraded the level of comfort and amenity in the building, at the same time you're giving the image a bit of a makeover, and I think making it more popular. So moving on then to William Wilkins, 1822, New Court, commissioned by, when the Wordsworth's brother, the poet Wordsworth's brother, was the master. Trinity was at that stage not a very wealthy college. It's rumoured that William Wilkins himself paid for the stonework on the river elevation. A precedent I was very keen not to follow. And he originally designed it as a Greco-Palladian building in response to the Wren Library next door, and then lost his nerve halfway through, or the college lost its nerve halfway through, and it was recast as a kind of neo-Gothic building. And when we took the plaster off the inside of the river elevation, we found the stones in place in the walls to form the very much larger rectangular windows. So it's obviously a change that happened while it was on site. This is the first image of the completed building from 1840. and that's looking towards the south range of Neville's Court, which is much older, obviously. And then there's this photo of 1865. The building, the river elevation was clad in stone, but all of the other elevations, and except for Garrett Hostel Lane, were finished in a Roman render, which was then a relatively innovative material from one quarry in Kent, and it's a natural render product, but its natural color is quite dark pinkish gray. So the building was finished with a lime wash, which was a kind of lovely ochre color. And the other things to note, I think, are that originally the windows were LED lights in metal frames. The window tracery is cast iron, and again that was quite innovative at the time. And the chimney pots, some of which had already come down, were also cast iron in the original design. But everything was treated in a, as far as we can tell, as a kind of warm ochre color, and then the windows were just painted black. But by 2010, when college asked us to look at the building, the stone elevations were in pretty good shape, but some of the gutters and downpipes had split, so there was some issues of kind of leaking. In the 1970s, the building had been re-rendered in Portland cement render, and they had very carefully color matched it to the now bare Roman render. So the courtyard, when you all knew it, will have been this pretty dingy, dark grayish pink color. And the only thing the college had taken real license with was the Garrett Hostel Lane elevation, which they had moved windows around quite a bit. And they'd built rebuilt the roof to all three ranges in order to make new rooms up in the roof in the 1970s with under Donald Insell's guidance. And internally, the rooms ranged from the very lovely room. This is Andrew Huxley's rooms in the archway overlooking the avenue. Most of the rooms had been iteratively compromised, I think is a polite way of saying it, by the introduction of vertical service risers and hand basins. We found the original recesses in the walls where the basins and ewer stands would have been. So in 1821, the gyps or scouts or the bedders would have taken bowls out and put them on stands in the courtyard and had a ewer of hot water for students to wash in. By 2010, the college had got around to putting hand basins in, but it wasn't. They were still pretty basic, and some of the rooms had been really carved up. So on the right, a tiny room in the loft. The rooms were on the ground floor were cold and dark and damp, and on the top floor, because the heating was run all year round in order to make those ground floor rooms habitable, the top floor rooms were incredibly hot and had the windows open more or less all year round. The stone stairs, very heavily eroded, largely, I think, by bedders mopping rather than footfall. The kitchens which opened directly onto the staircases with no fire separation, and there was still a fully operational gas installation through the building. And as the college had iteratively responded to the needs for increased facilities and amenities, there were loos and kitchens and showers had basically been stuffed into every available corner and under every stair, on the top of the stairs. It was in a bit of a state, and the fire officers weren't very happy. In terms of the fabric, you can see here elements of the original in a kind of protected doorway, the elements of the original kind of ochre lime wash that the building will have been finished in, contrasting with the flat pink Portland cement render from the 70s. And at some stage, it had been decided to paint the cast iron in a kind of beige color. So the integrity of the building's appearance had been undermined, as well as the fabric of it, by this kind of 180 years worth of tinkering. So the college brief was to create 21st century accommodation within the listed interiors, comply with all the building and fire and other regulations, provide complete new and adaptable service installations, renew the facades and the character of the court and the character of the rooms, and reduce energy use and carbon emissions in line with global targets, i.e. an eighth of where we started from. At the early building committee meetings, there was a conversation about, should we just demolish it? Is it going to be possible? Should we just demolish it? And the answer is, well, how long do you want it to take? Because it might take 180 years to get planning consent. The other, which we proposed, was to retrofit it with a 3-stage reduction of emissions. And this has become a very simple mantra, but it really works, because if you say we're going to reduce energy use to a 12.5% of what it was before, people go, oh, it's impossible. It's too big a jump. We can't do it. So what we said was, we're going to halve the demand. So we're going to halve the energy loss of the building by insulation and air tightness. We're going to double the efficiency of the plant, the ventilation, heating, lighting plant that meets that demand. And then we're going to halve the carbon in the energy supply to that plant by using renewable supplies. So that half and half gets you to an eighth in more digestible steps. So the holistic proposal we came up with, and this was before we'd been to talk to the planners or the conservation officers or Historic England, was we're going to make the building airtight. We're going to insulate it, including double or triple glazing. We're going to introduce mechanical ventilation with heat recovery, which is these dotted lines. We're going to use the chimneys and the fireplaces as a way of delivering that ventilation, so you don't have ductwork passing through these listed interiors. And we're going to reduce the energy loss to the point that we can use underfloor heating, low temperature underfloor heating, to heat the rooms, and that will be powered ultimately with a ground source heat pump array. And then we're going to put photovoltaics on the south-facing slopes of the roof. Now, the underfloor heating's in. The college haven't yet installed the ground source heat pumps. I think that's a question of time and a degree of disruption fatigue. And the photovoltaics haven't yet gone on, but the consent is there. So how we went about this, given that no one had ever done this level of intervention to a listed building, was to just sit down with the junior bursar and say, okay, so what are the risks we're facing? One is about fabric and insulating. We're obviously not going to insulate outside the listed elevations. We're going to insulate inside the building. There was a lot of myths about whether you could do that to a solid wall building or not. There was clearly a risk, and the college were very clear. They cared more about these risks than Historic England or the conservation officers. The building was 180 years old. They wanted it to last for at least another 180 years, and they didn't want to do anything that was going to damage it, either its fabric or its character and its heritage significance. But the third real risk was the whole building consent process. How you get consent for something like this in the context of no one having done it before. So we did a lot of kind of desktop review. This was the relevant research into retrofitting historic buildings and designing for future climate. Some of it academic papers. The guy called Joseph Little in Dublin, writing some pretty horrific research on the growth of mold in internally insulated buildings. I think he overstated the case, and we had to do our own parallel research to show that it was wrong. And there was this amazing tool, which is still available online. It was originally commissioned by Historic England, but it's now hosted by Sustainable Traditional Building Alliance. And it doesn't tell you what the answers are, but whatever part of a historic building you want to alter. So I've just highlighted walls here. It identifies all of the other things that a change to the walls will affect. All of the need for ventilation, the way in which heat in a room is distributed, what's happening to the chimneys, the effect it has on doors and window openings, the potential effect it has on the floor, and that's floor structure to do with moisture and thermal movement in those bits of connected fabric, and the effect it has on the roof. It's a really good prompt. for thought when you're looking at retrofitting a historic building. It's a good tool, and was just emerging when we were talking about New Core. So there were, as I said before, there were absolutely no precedents for this kind of work, but there were lots of myths. And one of them, the primary one that Historic England and the conservation officer were saying is, well, you can't internally insulate solid walls. You just can't do it. It's too risky. You will get dry rot. So we set about understanding the fabric performance of the existing building. There were 6 kinds of measurements we took: in situ U value, hydrothermal gradient monitoring, thermal imaging, air pressure testing. We built an on-site weather station, because there isn't one in Cambridge that works fully, but Trinity put one on the roof of the Wolston building. And all of the international hydrothermal modeling tools are based on modern materials. And we say, look, this building was built 180 years ago on a shoestring. The bricks will have been cheap bricks, and they will have used the best bricks from each batch out of the kiln on the outside faces, and the inside it will be any old rubbish and rubble. So that's not going to behave like a contemporary standard brick of known conformity of dimension and thermal and vapor transport properties. So we need to measure the actual building rather than rely on any of the online tools or assessment methods. So this is testing air tightness and thermal imaging. I mean, you can see radiators through walls on Garrett Hostel Lane Bridge, such as the thermal performance of that wall. There were a lot of leaks. We had well, again, the accepted wisdom was you'd have a figure of about 19 meter cube per meter square per hour at 50. We got 11, so it wasn't as bad as the SAP analysis or other things would predict. We wanted to get to 3, which was better than building regs, but not as good as Passive House. The in situ U values, this was a really critical thing, because actually all those irregularities in the thickness of a wall add to its thermal performance. So a standard U value calculation of a wall using Bill's desk or a proprietary tool suggested that these walls would have a U value of about 0.94. What we actually measured was between 0.59 and 0.78 with an average of 0.69. So that's a 25% difference. And what that does is save you from the risk of over insulating in order to reach a target, and therefore causing yourself problems of mold, condensation buildup and mold growth. So we aimed for about 0.25, which is better than building regs, but again, not as good as Passive House. The interstitial hydrothermal monitoring, that's you put probes in the wall at different depths, and you measure on the top the temperature, on the bottom the humidity at various points through the wall, and if those 2 lines cross, then you get dew point, you get interstitial condensation. So the wall was working pretty well beforehand. It was quite an intrusive process, but what you find when you take a core sample out of the wall is there are lots of gaps, and those gaps actually help your thermal performance. The Heritage Agency said, yeah, but look, you're just talking about models. What they don't mean anything. So the college decided they would build a sample wall of the insulation proposed. So on the right in this room I6 is a sample installation and a control installation to see whether putting insulation on really was going to cause a breakdown of the fabric. And we ran this for a year, and that's the control test. Oh, the word July has dropped off my slide, sorry. Basically what it shows is that the insulation zone here, there is a steeper thermal gradient and a slightly steeper moisture gradient, but actually the lines don't cross at any point. The conditions in the wall outside the insulation are more stable than they are in the control situation. Now, we still don't know yet whether that's a good thing or not, and only time will tell, but all of one's instincts are that stability is good for built fabric. And then we use this German hydrothermal modeling program called WFI, and it produces this kind of output. And I found it complete. I mean, the engineers could understand it. And the college set up a technical scrutiny committee of fellows, and all of this stuff had to be presented to them on a regular basis. And they said, yeah, we agree with that research. Yes, we think that's a reasonable assumption to make, or a reasonable inference to draw from the data. And that was brilliant, because I think having the college with us at every step made us feel much more confident, but it also fed back into the college's confidence of what we were proposing. But I found this completely meaningless. And is 80% a good thing, or is 44% a good thing? Is it good enough? So we went back to basics and said, what is the risk we're talking about here? It's the risk that you create conditions for mold growth. So here are some isopleths of mold growth. On the left, optimum substrate, that's agar jelly. That's O-level biology. Agar jelly, mold growing. Biologically very usable substances, that's things like building paper and modern softwood. And on the right, hardly usable substrates, that's actually things like 180-year-old pitch pine floor joists and concrete and brick. And we said, let's measure our risk, our output from our WUFI model against that. So on the left-hand side here, if you did what the industry was saying we should do, which is to use a phenolic foam insulation with a vapor control layer, you find that over 30 years, this is 30 years worth of model conditions, and you're growing a lot of mold. On a sheltered elevation, so that's a south-facing elevation, you're growing a lot of mold. On a sheltered elevation, where there's not much rainfall, and water is moving, moisture is moving through the walls from the outside to the in, as well as being generated by users and showers and kettles and stuff internally. So if you build a complete imperforate barrier, which is in itself almost impossible to do on site, you will have problems on some elevations and maybe not on others. If you use wood fiber insulation, which is vapor permeable, allows moisture from the inside to move outside to move through to the inside and vice versa, then actually you have a broader range of conditions, but as long as they don't cross that red line, you're probably going to be okay. I mean, it turned out 100 mil was too much for new core, so we used 60. But I'll come on to that. So another myth is, oh, if you're going to insulate inside a building, you've got to insulate the party walls that meet the outside wall, because they will be cold bridges. Well, we did a lot of thermal analysis, and we found that that's rubbish. You create cool bridges, but they're not cold. And if they're not, as long as those cool bridges are greater than about 13 degrees, you're not going to get condensation. These are the walls at New Court. We were modeling the coldest point being 16.8 degrees. So actually comfortable. And if you expose a cornice, so the college again brilliantly said, we don't want to do that thing where you put insulation on the wall and you've taken the cornices off and you put the cornices back on the face of the insulation. We want to leave them where they are, and we want to reveal them to show what we've done, to manifest that we've laid this panel of insulation onto these walls. That caused a huge kind of, oh, there'll be mold all over them. But actually, the predictive modeling showed that wasn't going to happen. This is actual monitoring on site, showing that there is no conditions for condensation on those existing cornices. You must say if this is getting too technical, because I could go on about this for hours. One of the other myths was you can't put underfloor heating under old boards. They will crack up and dish and cup and whatever. But actually, these floorboards were 180 years old. They had actually done all of the shaking and moving and twisting and cupping and buckling they were going to do. So we lifted the floorboards, we put in the underfloor heating, we laid the floorboards back where they came from, and they have been absolutely fine. So this is a photograph of a finished room, overlaid with a drawing of the service installation. So we took the sorry, go back to that. We took the suspended ceiling lights off the ceilings and put back wall-mounted lights. I mean, originally the rooms would have had candle candelabras on the walls or gas lamps. So they will have been lit from the walls upwards rather than the ceilings downwards. So we built this fitted furniture that contains all the service runs and things like the lighting. And this is a little thing, is an absence detector. I don't know what you guys were like when you were at Trinity, but there was a real acknowledgement that students would go away for weekends or longer periods and that without telling anybody. So if you're away for more than 48 hours, the absence detector makes a note, and all of the heating and electrical supplies are kind of turned down to a base level. So you're not running the building at full, not running the room at full energy consumption while there's nobody in there to enjoy it. And in the window head, we built some little contactors, which if you open the window during the heating season, the heating goes off. You've got tempered fresh air, the room is adequately heated, but if you decide you want to get a whole load of fresh air, then you'd otherwise be throwing heat away, so the heating sets back. When we proposed to use MVHR on the existing chimneys, there was a bit of a rebellion against that, because you can't do that. I don't know why, but we laser surveyed some of the chimneys, some of the chimney stacks, found that they were fine. And actually the operation of getting a flue liner down turned out to be much easier than anyone had expected. And the plant all sits in the roof. This was the first time we'd ever used Revit, BIM 3D modeling, to make sure it was going to fit and that we could make all the connections. And then the builders still didn't believe us that it was going to work, so they built a mock-up in the workshop of how that stuff was actually going to fit and how they were going to be able to get at the filters and the operating. So then that kind of, I think, deals with the technical stuff. But then there was the issue of significance and heritage significances. And we started off going through all of the normal things that one do. So this is photogrammetric survey of the existing fabric. We catalogued all of the rooms in terms of their hierarchy of significance, and how many of each kind there were, and logged all of the fabric. You know, have they got original cornices? Have they got original fireplaces? And realized that was playing into the kind of dialogue that Historic England, the conservation officers, normally like to. What was actually significant about New Court, and this is the photo of B staircase. So you had Andrew Huxley at the bottom. Sorry, Andrew Huxley living there, and 9 undergraduates and some teachers. And what was amazing about New Court is the way that it accommodated each new generation of students with kind of equal generosity, untrammeled by, oh, you can't do this here, you can't, you know, this fabric's important and sensitive. It's its robustness and its adaptability to each year's generation of new students was actually its most important aspect, its most important attribute in terms of the college and the way in which it embodied collegiality. So we said to Historic England, look, this is one staircase. This is a variety of ways in which these rooms are used and or abused, and that's its most significant. That's the most significant of its heritage qualities. And what we want to do is to modify the building in a way that preserves that adaptability and its habitability in this very collegial way. And actually owning the argument and taking that to Historic England was a very important component of getting consent. But we modelled, this is a 1:10 model of a room, showing the insulation laid into the external wall, the cornice in its original position running along behind that, and the early designs for fitted furniture and whatever. We did lots and lots of maquettes and mock-up full-size maquettes of how this was actually going to work, which was brilliant because you could give it to the builder and say, do that. And then in the joiners workshop in the brew house, we built a full-size mock-up room. Again, partly for the college's benefit, because originally they said, oh, we want the same kind of paneling as we've got in the Wolfson building, but actually that was too bland and neutral. So we came to this form of timber paneling, and then actually the building committee said, we've got all this paneling. Why can't it be shelves and cupboards and use it more richly? Another myth, you can't double glaze historic windows. We had wanted to triple glaze the windows, or replace the windows with triple glaze, because the windows weren't original. As we could see from that earlier photo, they were originally LED lights in steel frames or iron frames. And that was this was a real, very difficult argument. And going back to the slide ahead of the proposals being holistic, we explored 15 ways of dealing with the windows, from doing nothing to replacing them with triple glazed or having secondary glazing. We analysed the contribution that those different options would make to the heat demand. And we said, it's a tipping point. If we use more energy than this, then the underfloor heating is not going to be viable. The ground source heat pumps won't work effectively. Basically, you can't cherry pick which elements of this project you like or don't like from a heritage perspective. You have to do them all. And we found that there was a handful of solutions which did work, and the one that we actually did and ended up proposing was to take the existing timber windows and put slimline double glazing in them. And the reason we want to do that, on the left is a picture of a building at Downing where they had been persuaded to use secondary glazing. And the reason that Historic England likes secondary glazing is it's a reversible change. And our argument, and the college's argument, is, well, for what potential future condition are we mortgaging our current enjoyment of listed buildings? Secondary glazing gives you this very funny flat dead effect and that weird internal shadow, and very difficult to use. Actually, you open the inner sash and then you've got to reach up and open the outer sash, and if you're expecting students to do that reliably and properly, then maybe you're on a loser. So the college workmen joiners made up a complete facsimile of an existing window, and we put double glazed units in it with a kind of Ripley outer glass leaf, and we installed it and said to the conservation officers in Historic England, one of the ground floor windows in this court has been double glazed. And they said, oh, it'll stick out like a sore thumb, it's an alien technology, we'll spot it in seconds. And after 10 minutes they came back and said, actually, we can't see it, you haven't done it. And you can't in fact tell that they're double glazed units from any further than 2 feet, 3 feet. So that was a real victory, and sadly it's a battle we have to fight on every single building since. And you meet Historic England on site and say, we're going to do this, and they go, no, you can't do that, you've got to use secondary glazing. And we have to go back and say, look, we've been through this before, surely this time we don't have to go through it all again. But that was a significant, I mean, so we've managed to retain the historic fabric of the window frames, but dramatically improve their performance, both in terms of putting in double glazing, but also routing in lots of weather seals and draft seals into the window frames and sashes. Not really going to go into the long national heritage and local policy arguments, but just to say that we decided to frame the listed building application under 3 questions. One is, what are the heritage values and their relative significance, but including things like optimum purpose and ongoing viability and collegiality. And then, to what extent will the proposals harm or benefit these values, and making sure that they were always acknowledging the things on the other side of the scales that we were going to do, that we're going to improve the heritage benefits, the heritage significances, replacing the defective render with a more sympathetically coloured lime render, refurbishing and repurposing the shutters. All these were benefits which the naysayers like to ignore. And then, putting Historic England to one side, we then said to the council, and it's ultimately the council make these decisions, are any of the harms outweighed or balanced by heritage or other benefits? Like, what benefits would arise from the proposals? And environmental sustainability was the lead of those, but also the fact that Trinity were doing all this research and monitoring that was could then be disseminated to the wider sector. The whole knowledge transfer business was something that the then master Martin Rees was really keen on. The council decided that listed buildings must evolve if they're going to remain in viable use, and they can't all become museums, so we're going to give it consent. And that was then ratified by the Secretary of State. So the outcomes of the project: preserve the character and viability, save energy, increase the comfort of the fabric and the occupants. There's a whole thing about policy change and dissemination and the methodology. Oh, I'll come on to that. And post-occupancy satisfaction. So these are the historic interiors. These are kind of overlaid on the right with the service installations, and on the left with the monitoring that we built in. So we could check that what we had said we thought would happen has happened. And that we're now in the 7th year of monitoring, and the building is outperforming the models in terms of moisture and safety. We've installed, you know, contemporary levels of amenity. So not, hand basins in proper tile surrounds, ensuite bathrooms, with a kind of clerestory light that allows you to see the footprint of the old room as the cornice runs around. This is a Grade 1 listed historic window. It's got double glazing. We've repurposed the shutters. It's it has retained its character. Actually, what's happened, looking at the latest figures from the college, we are at we've overachieved on the reduction of demand, slightly underachieved on the system's efficiency, and we're still waiting for the renewable energy. But we're doing better than we thought we would. In terms of the monitoring, I said this is still ongoing. The relative humidity in the walls is better than we modeled, than we predicted, and over nearly 7 years of monitoring, we've had no real incidents. The conditions in the room, the MVHR is delivering really high quality air with very low levels of carbon dioxide, even when students have parties, which of course they don't. The CO2 level rises, but it's controlled back again within an hour or so. And we added this question to a college questionnaire, asking students to rate whether they would recommend a student to live in a room in New Court. And the junior bursar and I at the time, and I said, if we get 50% yes, then that's a result. But actually, we got an 80% result. So, I mean, there were people chanted about the person in the room above them playing the violin, but that's nothing to do with the building. So people will always be unhappy about something, but actually, the idea that you got 80% of people saying yes, it's a room I'd recommend someone else was a result. The methodology we developed for this has become embodied in local planning policy. So Cambridge local plan asks for anyone who wants to do work to a Grade 1 listed building to go through the same steps as we did, to understand how the building worked before you do anything, and to provide data on the environmental performance of the building fabric, to understand it. So previous junior standing bursar said that we've already reached 80% reduction in carbon footprint, and one of the residents said it's the nicest place to live in college. So on those kind of soft metrics, we think it's been a success. It's won awards. The press are very enthusiastic about it, as setting a kind of benchmark for how we must do these kind of things. You know, it's still nobody has looked at a Grade 1 listed building with this degree of for this degree of retrofit. So the college is still out there on the leading edge in terms of research and innovation. Very quickly on some lessons learned. We don't teach people how to deal with the right kind of materials. They don't understand lime. They don't understand that architects are happy for walls not to be plumb and square. You know, historic buildings aren't. Why should new buildings are? New estate housing is. We need to teach people better. And the shortage of I mean, the people who did the render on the building came from they were Romanian, and they had just been re-rendering the Colosseum in Rome. They are not working in the UK anymore. I'm afraid that the combination of pandemic and Brexit has reduced the pool of really skilled workers in the UK. This is what they like to do. This is a bit they enjoy, driving around ground floor room, grade 1 listed interior in a digger. This is what we persuaded them to do, which was taking the windows off site and reglazing them and repairing them in really comfortable workshop conditions where they could do a really, really good job. This is all of the cornices and architraves, again, taken off site so they could be dealt with carefully and properly, but carefully labeled so they went back in the right place. These are great pallets of all the floorboards taken off site to have all the old nails stripped out of them and to have the black painted finish taken off them. In order to kind of reach the level of quality, we were on site every day. We didn't want the builder to find things and make up their own minds as to how to get round problems. And although Neil Steen, the college guy, was there all the time too, we were on hand to answer those questions before they became headaches or significant causes of delay. Sorry. We had to prohibit the use of power drivers. People going with a screw and over tightening something and destroying an old cornice or a bit of historic joinery just through enthusiasm. But the contractor also increased. They increased the proportion of their site staff that were managing and quality assuring from the normal kind of 7.5% to 3 times that. So they had a lot of black hats on site checking quality, and we organized a whole kind of recurrent series of talks about how you use lime plaster, how you use insulation and the linings, because the turnover of staff on a site like that was quite extraordinary, and you just get to a point where you thought everything was going really well and you discover someone wasn't using the right kind of saw because it just started and no one had told him. We found that the use of models is really good, but that if you've got your research right, reality will exceed the model in terms of moisture risk and air quality and comfort. The monitoring that's been built in has also been an incredibly useful early warning system. So this graph on the right shows the point at which it became apparent that a tennis ball had got lodged in a gutter, and the gutter was backing up and making the wall beneath it wet. But before the point at which that water damage became visible in the finishes to the bedders or the students or whatever, the monitoring system was recognizing this really high peak of moisture, and the people doing the monitoring online could ring the college and say, I think you've got a problem. And that's when they found the tennis ball and it was removed and the conditions have recovered to their kind of ideal levels. So really useful side effect of this monitoring is the aversion of disaster. And I think the other thing we've learned is that the speed at which the electrical grid in the UK is becoming decarbonised has exceeded our expectations. The electricity available on the cheapest tariffs is less than a quarter of the carbon density identified at the beginning of New Court. But as discussed earlier with regard to the national grid, the capacity of the grid to power all electric heating and hot water supply is very limited. And my calculations are that New Court will fit within the kind of limits of energy supply in 2050, and that it sets a benchmark for how we deal with lots of other, if not all, existing and listed buildings. Okay, hands up, there has been some overheating. For health and safety reasons, window restrictors were put, opening restrictors were put on all the windows, so they wouldn't open more than 100 millimeters, which, given the thickness of those walls, meant they weren't seeing much fresh air. So the rooms have overheated, and we have now taken the window restrictors off. And you know, the overheating is a very small proportion of the kind of conditions in the rooms, and it's obviously largely in the summer when the college don't have conferences, so maybe some of the alumni get slightly overheated in the summer, and we have to deal with that. The behavioural interfaces I talked about, I don't think I would bother to do those again. I think they were quite expensive. I think they added to the complexity of the control system. And with the things that have been brought about by the pandemic, I think the college now have much better ways of knowing who's around and who's not. And the students learn pretty quickly that if they that they don't need to open the window to get fresh air. They've got fresh air delivered miraculously into the room, and they haven't felt the need to open the window. So I think those are things I would probably, well, I'm not doing again in subsequent projects, let's put it that way. Yeah, so that was it really. It's a pretty extraordinarily detailed project. I say it remains kind of out there as the only building that's been dealt with like this. And I without the college as a client, and without their not only commitment to the ambition, but the scrutiny that they put all the proposals under. So that the mock-up room was visited by almost all of the fellows, who all had comments and allowed for the modification of the design. The technical scrutiny committee were a joy to work with, because yeah, the college joined in with the whole process in a really amazing way, and I've not ever come across another client who had that kind of approach to the process or to the outcomes. So
thank you, Oliver. This was fantastic, absolutely fantastic. One question is, this monitoring which you built into the rooms, that's really fascinating. Do you build that into every room, overall, or the sample?
No, I'll just go back to that slide.
And how is that? Just for testing your retrofitting, your building project, or does that remain there forever to kind of manage a building overall?
The college wanted to do it for the college will do it for 30 years. The historic England and the city council said, no, we can't manage more than 7 years.
Sure.
We won't necessarily have the resources. There are three. Look, if you look at the plan of the building, there's monitoring in each of the southwest and the east elevations, at court side and external elevation side. So there are 12 locations. There are 12 installations like this. That have the full hydrothermal gradient monitoring and in situ U value, and little tags measuring the humidity and the temperature of bits of old joinery that are still there but are covered up. And they're all very happy actually as we speak. So that we didn't move the skirtings, we left them. And we've put little tiny tags on where there are floor joists built into the wall, so we can see if the conditions there have changed. And actually, again, what we found is they're more stable than they were before. There is and as observed, this monitoring has had the side effect of giving early warning to the college if there are defects, or a tennis ball lodged in a gutter outlet.
Yeah, his tennis ball story is very interesting. It's great. When did you complete the work?
2016. It was opened in September 2016 for students.
I think I stayed there one night in 2018. I think I stayed there, so I loved it.
But it'd be interesting to know from the alumni department what people think of it. Presumably, you get feedback from gatherings and so on.
Yes, it made me smile when you said about the heat in the summer, and that obviously no conferences, but alumni do comment. Now they certainly do comment on the heat in the summer, and last summer was a particularly hot one because we had an annual gathering on the day it was 40 degrees. So there was that was a problem across every part of Cambridge, and not just in old buildings. Alumni do have comments on it. Sometimes they walk in and they say, what's happened to the colour? The colour of the outside of the building. But they do comment on how good the spaces are and how practical they are now. for us when we're doing our events and so on, we'd much rather have more rooms that have the facilities that Newcourt now has than
strangely, I seem to have lost the slides of the outside elevations. I'm just going to try and find one, and I'll post it up on this screen.
Okay.
I don't know where that slide has gone. No, well, I think the extreme weather events are, as you say, a problem everywhere.
I mean, one thing which England is kind of lucky is that they are not, how do you say, the risk of earthquake is fairly low now, because in Japan you have these very large earthquakes, so you have an additional component to consider and to take into account in the planning, and which you can see in Turkey and so on now with these big earthquakes. I mean, even in England, the risk of earthquake is not zero. I mean, if you look up on the internet, you'll find some earthquakes in England as well.
Nice.
This is the picture you were looking for.
If they go on fracking, it's supposed to get worse, isn't it, Gerhard? But they probably they won't.
Well, on April Fool's Day, during this process, we made images that we sent to the junior bursar of other ways of reaching net zero for Newcourt, and one was an aerial view of the college with every courtyard laid to short rotation coppice willow, and what that would be like in main court. And then the second one was actually of a fracking rig in Newcourt, because Cambridge turns out to be at the top end of a particularly kind of potentially rich fracking geology. I've omitted those from this slideshow. But no, so this is the courtyard re-rendered in lime render, and the cast iron window surrounds painted to match, which took a lot of doing. And again, the junior bursar and I would meet every Monday morning on the scaffolding and work out whether this was the right color and how it was looking as it dried and as it weathered. But it's just a much warmer. It's just a much warmer space. And this was taken just when the grass had not been reseeded fully in Newcourt, but that's now set to wildflower meadow, isn't it, Phil? And I think that for the first time ever, you're allowed to walk on the grass.
Wow.
In Newcourt.
There is a pathway through the wildflower meadow on the grass, indeed.
Right.
It's obviously been cut down at the moment, but the plan is that it will come back again once the growing season starts.
If you don't mind, I'll see if Matthew wants to have some discussion. Who is, I told you, he's the friend of Alan Babington Smith, who is heading the Trinity job in China. And he suggested his friend Matthew, he's doing similar restoration work, I think, in China. So Matthew, are you here? Matthew? I'll have to see response.
Gerhard, while Matthew's doing that, I'm afraid I have to run away to a meeting. So I just want to say thank you very much for that talk, Oliver. It was really, really good.
Great.
And enjoy the rest of the discussion.
Thank you so much, Phil,
Thanks,
and
Phil.
also for all your help and cooperation. Bye-bye. Matthew, are you here? He doesn't respond. So Matthew doesn't respond. So in that case, Martin, what about Martin? Do you have...
Fascinating. Yeah. I mean, it seems to me that it's very nice to have the characteristics of historic buildings justified in this way, that they are actually retrofittable and can be made to work, and it's going to be a huge problem. And one can see how a client with the resources that Trinity has been able to take that on board, and that surely is potentially a very useful thing, because you've got an example where you can point at a grade 1 building and what you did, And for people with smaller units, I don't know, maybe a solicitor's office in sort of 18th century buildings, and the scale is smaller, and what can they do? And you can kind of point at this and say, oh, it's doable, and that will give people confidence not to panic and do hideous things to historic buildings. So I think having had this opportunity to kind of get the information out there is and the way you talked was so lucid that I feel that that's something that you'd be, well equipped to do. It's going to be a very important issue.
I think that looking back on it, that it took us 3 years to get listed building consent. It took us 3 years to work out how to get listed building consent and what we needed to do in order to win the arguments. And that has now, we're just on site with a project for Lady Margaret Hall in Oxford.
Oh, yeah.
That process took months because we were able to cut right through it. This is what's important. This is how we're going to handle it. And obviously you can refer the conservation officers and historically to this as an example, and they can come and have a look at it. And yeah, it has. So the subsequent projects have been made much easier because of the kind of research, the time really that Trinity put into getting this right.
Yeah, in a way, I mean, it's obvious from what you explained that there has been a huge amount of investment in research and also capacity building and knowledge building, which you can leverage in future projects, of course.
Yeah, and
fantastic.
We've done. It hasn't necessarily resulted in a huge amount of fee income, but we've done a lot of talks like this. December, I'm talking to the Houses of Parliament who've decided that in their retrofit they should think about sustainability, and that hadn't dawned on them until
really
someone pointed out to them that an older neo-Gothic building Grade 1 listed building had achieved significant energy savings. It might have been Martin. And so suddenly they said, oh, how do you do that then? And I've been down to talk to them, and they're just working out how to do that. Because I'm not necessarily interested in the House of Commons chamber or the lobby or the House of Lords, but the thousands of rooms in which people work every day and are expected to work in pretty grim conditions. I don't think you would do New Court, this kind of level of intervention, to the college chapel or the dining hall, but to places where people are either living or working, for long periods of time. Then it can make a difference, and a lot of those spaces are, by definition, not as special. I think, but those are the ones that are consuming lots of energy. They're ones that people are living and working.
I mean, what was very interesting also is what you mentioned is that from the point of view of what's it called, historic England.
It used to be called English Heritage, but they got rebadged by David Cameron.
Renamed, yes.
That you brought in the argument of the issue is not to conserve it as it was when it was built from the building itself, but from the usage and the purpose. That's a very interesting kind of, it's a bit philosophical, but it's also very practical because it gives you a kind of a rule or a rule book how to make the decisions in giving the permission.
Because if you go along with the restoring it bit, and this is something that came up in Martin's talk actually, what iteration of its existence are you restoring it to?
Yeah,
you're restoring to the original. So you take out all the plumbing and you have the students washing in hand basins in wash basins in the courtyard. Yeah. Or where does the authenticity lie?
Yeah.
Which period in its history? And maybe and again, the authentic. We argue the authenticity lies in the fact that it does its job really well.
Yeah. The other question which came to my thinking now is, would it be possible, and what would the effort be to make that a zero energy building?
I I don't think you can make it zero.
You think it's impossible? Oh, okay.
I showed a slide earlier showing, if you put another 1.5 inches of insulation on the walls, then you are running the risk of causing interstitial condensation and mold growth.
Yeah. Okay. So it's a balance between mold and
yeah. So there are fabric risks which get more severe the more you. But in a way, one of the lessons about that's now built into policy is that you've got to understand that risk before you start, because there was a real fear of precedent. In the heritage agencies, that people would go, well, at Newcourt they'd use 60 mil insulation, I'm going to do it on my building. And we went to look at a grade 2 star listed building in Exeter, which if you just did a desktop review of it, you'd have said, yeah, it's fine, you should do what Newcourt did. But then you looked at the rainfall patterns and they have 3 times as much rainfall. So actually the context is completely different, and that solution would be completely inappropriate and lead to very rapid decline of the building fabric. So I think you probably can't get to absolute zero. You can get to a level at which it becomes economic to offset or offsite. I don't know what land holdings Trinity have, but you can imagine that you might do soil remediation or tree planting on land that the college own, rather than relying on a kind of third. So I think there will always be some offset or offsite with regard to these buildings. I think it's very difficult with an existing building. I mean, new buildings, you should be able to.
I think an issue that we are going to have to face, and that if you finished in 2016, you probably wouldn't have felt the need to address because it hadn't really emerged, is if the kind of heat that England saw last summer is going to become sort of standard, then a whole lot of the way we have built is not going to be able to cope with the summer heat. And that is a situation that simply hasn't existed for most of Northern Europe up to now, but I think it could be an issue. I mean, living in Japan, you do hit it, and with high sort of humidity as well, and there's no alternative in the buildings that they've got to air conditioning effectively in that. I don't know how England's going to cope with that.
We were asked to explore what would happen in the worst of the model future climate scenarios. And there are some things that are built into this that will really help. So when the ground source boreholes are installed, then we will be able to use them for cooling. We will be able to pump cold water through the heating system and cool down the floors. We can, at a flick of a switch, increase the ventilation rate through the MVHR. So we can increase the extent to which air is moved through the building, which can have a cooling effect, obviously. But in the most extreme,
moving air is certainly helpful.
Yeah, when we came to the most extreme conditions in the probabilistic data from the UK CIP, we found that the only answer was to plant creeper on the outside of the building, to actually have an outer skin of foliage which would just take the incident sunlight off the building fabric. Trouble is, that's not a rapid response. And
no, it's probably quite effective, because there is no question. I mean, that's one of the issues that comes up in Japan a lot, is that they have made their urban environment so hard. It's sort of concrete and it's asphalt, and most of the softer materials and the vegetation isn't there. And where there is vegetation, the amount of heat that the impact is incredible. It actually does completely change the situation. You've got trees all around. Of course, I mean, then if you get a typhoon, then that becomes a danger kind of situation. So you have that, but just coping with a really hot day, the difference between walking under trees and there not being any is enormous, actually.
Yeah, I think the cooling effects of urban greening is currently underestimated, and the contribution it might make in future climate. You know, having said that, I mean, we're working in in the centre of London, and with the ambition to plant lots of trees, for example, at the new Vauxhall bus station. And when you start talking about it in detail, you find there's no room in the ground. You know, the ground is full of cables and wires and pipes,
full of infrastructure,
and there's nowhere to put a root ball of a tree. So yeah, that's got to be sorted out. You know, the mayor or someone has to say, well, I'm afraid EDF, you've got to move your cables because we need these trees. But no, I mean at New Court, that the ultimate best answer was to green the building up. And I don't know if you certainly in the 70s, my memory is that the river elevation of New Court was quite heavily covered with ivy and maybe Virginia creeper actually.
Ivy is not good stuff, but Virginia creeper doesn't depend on sinking its roots into your fabric and tearing it apart. So that's something you can use. And there'd be things that you can plant and ways you could do it that would not destroy the fabric or
yeah.
So yeah, that's an interesting idea.
Well, are there any other questions?
I think we are coming to the end now. Thank you so much, Oliver. This was very, very fantastic. And I'm really looking forward to staying there again and maybe also meeting you in Cambridge. So if you come here to Tokyo, please let us know and join our dinner here if you ever come to Tokyo.
Well, I decided a while ago I wasn't going to fly anymore, but I have been prevailed upon to make an exception for a trip to Japan, which we've not yet done. So, yeah, we'll be in touch.
Oh, we can. In theory, you can come by ship. Actually, one of our members, he was one of the last people who were coming by ship here to work at the British Embassy in Tokyo. So in the past, the diplomats were going by ship before the flying became practical.
Well, with Zoom and Teams, then as long as there's a good satellite connection.
Okay.
Maybe it's possible to kind of keep working and as well as sailing around the world.
Yeah, but ship takes 3 months or so. It takes a bit long to Japan. I forgot now how long it takes. Okay, great. If you can come to Japan, please visit, have dinner with us here, or otherwise we'll meet you in Cambridge. Thank you so much for this wonderful discussion today. Thank you. Bye-bye.
Thanks very much.
Bye-bye.
Thank you.
Thanks, Gerhard.
Bye-bye.
Bye-bye.
Bye.